Welcome to the Think Factory podcast. We got one question for you. What keeps you up at night?
And I'm your host, Chris Santamassimo. I'm here today with a new friend, Peter Sayki. Pete is the president of SICAM Corp, which is in Hillsborough, New Jersey, right in our backyard. So welcome to the podcast.
Thank you. Thank you, Chris. Good morning. Thank you.
So I got introduced to Pete recently, thanks to the fact that SICAM was honored as one of the award finalists, some of the best companies in New Jersey in Manufacturing Day, which is hosted by the NJMEP, the New Jersey Manufacturing Extension Partnership, which supports manufacturing companies in New Jersey. So I'm always excited to talk to folks at companies like SICAM because of all the interesting technology and the history behind the company. So I wanted to introduce that to our listeners. So take it away, Pete. Talk a little bit about SICAM and when you started it and what you're up to today.
Sure. Well, SICAM is located in Hillsborough, New Jersey. We started it back in 1990, just some time ago. And the reason that we started it was my partner and I, the partner who runs operations, and I do the sales and marketing side of it. Years in engineering and product development and manufacturing. So we have extensive experience in that. And that company was sold, and we were together, and we decided that, instead of going to work for somebody else and doing it all over again, we would take a shot at the American dream and go in our own business. And that's how we started.
Well, back in 1990, a little fun fact, you guys were really at the ground floor of what's now referred to as 3D printing.
Yeah, I'm glad I could laugh about it today because it was a little bit tough in the beginning. We went we found this technology. Actually, my partner found it, and we were deciding to go into something that we knew about, either engineering or manufacturing or design. Writing software. We were kicking a lot of things around, and we were very heavily involved with implementing computer manufacturing processes, robots and CNC machines and stuff like that. So my partner found this thing, and he came to me one day and said, they got this new technology out in California that they literally grow parts out of liquid plastic from a CAD file and make prototypes overnight. And they called it rapid prototyping. And it was pretty exciting. We said, well, let's take a look at that. And a guy by the name of Chuck Ho invented the first machine. I know Chuck, and he told me when I met him that he thought of it one night in 1985, came to him, and it took him from 1985 to 1989 to develop the machines and start a company. And he started selling the first 3D printed machine back in 1989 and in late 89. And we bought our first machine in early 90. So we started on the ground floor, and the first 3 years were a little bit rough because no one knew what the technology was about. It had a lot of technical difficulties with it,
to say the least.
Yeah, so it was on the ground floor. As a matter of fact, it might have been underground because we were having a hard time getting computer files from customers and setting our customer base up. And the first 3 years were a little bit rough, but we ended up getting through it and had a lot of milestones since then.
All the conveniences that we think about today in terms of how you transfer computer files just weren't available then. The high-speed internet and Dropbox and all those things that we take for granted today just weren't available.
Yeah, as a matter of fact, they used to send tape files to us when we started getting involved with a certain client base, and said we need a file, and it would be a tape drive that would send to us. But yeah, you're right, the technology wasn't available, and even then they had to FedEx the file to us. They had to FedEx the actual tape cassette to us,
right,
to get the file. The internet wasn't around, and it was pretty interesting. But the technology, what was great about it, and what Doug and I thought about was that, engineers, prior to 3D printing, engineers have to develop prototypes of new products. They have to design a new product, and they need prototypes to test how the design works. And that's what we did in our jobs. And, it's a long time process to do that. To machine a part, you get a prototype could take 2 to 3, 6 weeks sometimes.
Mm-hmm.
And to think that you could take a computer file and have it show up on the engineer's desk 2 days later was pretty amazing.
So you would print the prototypes in plastic, but what about prototypes that were in other materials? How would you deal with those?
Well, that's a good point. The first technology that came out was a liquid-based machine, and it was a photosensitive polymer. So a laser would take the image of it. How it works, how 3D printing works, is it takes a computer image. So if you had a coffee cup in 3D in the computer, in a 3D solid modeling, in the computer itself, it would take that file and slice it like a deck of cards. And one layer at a time, the bottom layer of the coffee cup would be traced by a laser over liquid plastic, and wherever it traced it and drew on the liquid, it would turn it solid, make the first layer. And that would go down and it would erase that layer and take the second layer and trace that over the first layer. And layer by layer, it would build the part up. And then when it was done with the last layer at the top of the part would come up out of the liquid, and there it would be sitting on the table, done.
It's just amazing.
Yeah, so the materials, to answer your question, the materials were inferior. I mean, they were good for what we call touchy-feel models. I mean, engineers wanted prototypes out of the real material that they were making the part in. So if they were injection molding the part out of a nylon, they wanted the prototype to be out of nylon. But this was a plastic polymer that was solidified by a laser. So they were able to put parts together and see how their fits were. But if you dropped the part on the floor back then, it would break. Mm-hmm. So it didn't have engineers like form, fit, and function. They want to see the form of the part. They want to hold it in their hand. You can see it on the screen, but if you're designing a faucet or a handle for a sink, you can't feel it until you make the prototype. Then you can feel the handle. And you say, oh, this is a little too thin or it's a little too small. So form and fit was what they were doing back then, but function was not working because of the materials. But as time came on, a lot more technologies came out over the years, and those were some of the milestones, getting into other technologies. Believe it or not, we still produce prototypes out of the first technology, that liquid-based technology. It's called stereolithography. Mm-hmm. However, a lot of things have changed since then. I mean, the materials have gotten better. And now in the last 5 years, I think it was, or maybe 8 years, a new technology came out called multi-jet fusion, which is a powder-based machine, and it fuses powder of nylon. So when the part is done, it's an actual nylon part, a very strong part, and it looks, feels, and functions just like if you injection molded that nylon part.
Wow.
So it's pretty cool now. And the other thing about the new technology, the latest one, is it's going away from prototyping. Even though we can still prototype with that technology, it's moving aggressively into manufacturing, what they're called now additive manufacturing. So we could actually produce 1,000 parts overnight.
That's amazing.
And they could use them on products and sell them. They could sell them.
What about when you get past the nylons and the plastics into some other harder materials like metal? That's probably still in the machine shop that happens.
Yeah, no, that's a great question, because there is 3D printing metal machines that came out.
Wow.
However, the plastic machines that I talk to you about now with the technology that can produce plastic parts quickly, the metal technology is not there yet. It's still like the original technology where a laser traces metal powder and infuses metal powder together. So it takes a long time to make one part. So if you had to have 1,000 parts, 3D printing of metal parts of 1,000 is not good to do. You might as well either machine them or cast them on the volume. But where the metal part is really that technology is really taking off is in very complex parts to machine. Like there's a quick way of describing that is GE is doing a lot with their jet engines with metal parts because they're so complex to make, they could actually print them.
Yeah, and you would think it's going to be just a little bit more exact probably in terms of the specs than it would be to try and make it out of raw metal.
Oh, that's true. That's true. But sometimes the machining technologies are the tolerances for machining parts are sometimes tighter than the tolerances that you could print them. So
Mm.
sometimes you still have to print a metal part and do a secondary machining operation on it if the
Got it.
tolerances are too tight.
Hmm.
But
Interesting.
that's different than the plastic. So
So,
it's
so really, you sort of ridden the wave from the very beginning up to what we have now in terms of the much advanced technology. What have you seen happen? Is this been a rapid process, would you say, or was it a really gradual one?
it's a gradual technology because a lot of the materials took a while, 3 or 4 years to develop new materials. They didn't come out right away with new materials. And then the technologies themselves took a while to keep refining over time. But yeah, a lot of technologies came and gone. And you're right, we were on the ground floor of it. And it's been exciting for us because we do use all the technologies that are today. And that's some of our milestones is that we kept up with all the technologies. It's one of what our customers are looking for, and we provide a service. Naturally, it's a service that we do. They need someone that knows what they're doing with the technologies and how to run the machines and how to make good parts and has the technical background behind that. In today's world, since we started, I mean, in the first 10 years, there was only like 300 of us doing this in the States. Now, everybody and their uncle says they sell 3D parts now.
Hmm.
Even if they don't have the machines, you could go on the internet and people were selling parts on the internet and they don't even have the machines. They're sourcing them from somebody else.
Hmm.
It's not the way we do it, though.
Because you're engineers at heart.
Yeah, and our company is very technically driven. So, this is a serious subject. When companies come to somebody like a job shop to injection mold parts for them, or a stamping house to stamp parts for them, they need a shop that knows what they're doing. Because those parts are for production. They're going on products. They need to be made per the spec. And our what SICAM does and why our customers like us is because we have not only the quality systems in place, we have the technical people in place, and we have the technical knowledge. A lot of my competitors and people on the internet don't even know how to do that to that level. So one of our challenges is naturally getting customers that understand our value compared to just going on the internet and clicking a button and saying, "Oh, give me a 3D part."
Yeah, because when you're going out to unknown parties on the web, you just sometimes don't know what you're getting in terms of the quality control.
That's correct. And so our focus has always been on partnering with our customers and being part of their team in developing a new product. And that's it's a serious subject.
Do you help on either end of the process in terms of the design before and
We,
after it gets to the 3D printing?
we used to do that in the early days of the 90s and early 2000s. Back in the 90s, people were having a hard time getting into the computer to do the 3D solid modeling. Okay, back in the early 90s, the computer automated the drafting process so they can make a 2D drawing or a blueprint, as they say in the old days. They can make a drawing on the computer just print it out and they have a 2D representation of their part. But what was really developing in the early 90s was what they call 3D solid modeling, where you could go in the computer and design the part in a solid form, and
Mm.
you could see it and spin it around. That started in the early 90s, and we had to do a lot of that for our customers because they didn't have that capability in the 90s.
Right.
But by the end of the 90s, everybody and their uncle was doing 3D solids on. I mean, kids in college now could do 3D solid modeling.
Hmm.
They could design a coffee cup, even though how well it. I mean, a coffee cup's an easy thing to design because you don't have too many tight tolerances on a coffee cup. Just that's the whole old coffee
Right.
for you.
Sure.
So a kid in college could design a coffee cup really quick on 3D solid modeling. So that technology, to answer your questions, we did that in the early 90s, and we still do a little bit of that engineering design. Some of our clients do come from us, but we don't have a large staff doing that.
Yeah, the software is much more available, much more affordable than it
Yeah,
was.
everybody produces their own files now when they develop the product.
Right.
So that kind of went away, and that we were happy it went away because we really didn't want to do the engineering design services.
Hmm.
Our business is to make parts for people by printing them.
Right. With engineering being a central piece of it, though, in terms of the quality of products that you provide.
Oh, absolutely. I mean, the customers, even that's a challenge to work with clients. I mean, sometimes they don't have the knowledge base of the tolerances that they need. I find it interesting because our client base is, what's great about the business is our client base is any industry you could think of, we could help. It's amazing.
Well, where do you focus? Where do you focus mostly, though, even though you got the ability to help across a lot of industries?
Well, we just focus on our marketing efforts of going after, explaining to engineers. We focus on engineers that develop products.
Right.
So if you're an engineer developing a product for a consumer product, a weed whacker, or if you're an engineer developing a consumer product like a blender housing, any engineer that's developing mechanical parts is the market that we can help. It's a pretty amazing business that way. So we don't try to, with our marketing, we do target certain channels, but the bottom line is we help engineers. So any engineer that's developing products, we could assist.
Engineers helping engineers.
That's right.
There you go. I think I just developed a slogan for you by accident.
It's pretty cool.
I bet it is. Absolutely.
And
I bet it is.
What's fun about it is we and actually everything's under non-disclosure with us. We're very serious about the confidentiality of developing products for our clients. So that's kept until it gets on the market. We really can't show it or talk about it.
Right.
And if you go to our website, the products that you see on our website are already on the market. We have approval to show them in the marketplace. But it's pretty amazing. We develop all kinds of, we make all kinds of parts because we get files from all different kinds of industries.
What are some of the most interesting things you've done? You don't have to talk about whose they are, but
I could
what
give
industries, what kinds of applications?
Yeah, I could give you some general comments on that. Because we do work in a lot of things, and over the years we've done so many projects. Some of the ones that remind me, I kick back on. If you go on our website and see this, back when I started the technology, I was out in California at JPL, which is Jet Propulsion Laboratories on Caltech's. JPL is on Caltech campus out there, and they're the ones that develop all the spacecraft.
Mm-hmm.
They developed our first satellite at JPL. So I was out there picking up, trying to meet new engineers for the business in the early days, and I get into JPL, and one engineer says, "Hey, you got to talk to my boss. We got some parts that we're having a problem making for our spacecraft." Now I know nothing about satellites or spaceships, and I go in there and I meet this guy Jim Statz, and he says to me, "Hey Pete, I hear you got this new technology that you could help us." He goes, "I need these waveguides done out of metal." And I said, "Okay, let me see them on the computer." We're looking at the designs. They were pretty complex geometry that they had channels down them that it's practically impossible to machine. He says, "You think you could print this?" I said, "Yeah, we can print it. I don't know if it'll work for you, but we can make them." So he ordered 3 of them. He said, "Let's try it." And, he talked about the prices. I got the budget for it. Let's try this thing. And we made these 3 waveguides. And actually, I made 4. I kept one for our company.
Mm-hmm.
I sent them the 3 that he ordered. And I talked to him later on, a few months later, how those waveguides work for you. He said, "They're so good. They work so perfect. We're putting them on the actual bird." Now, he called the actual spaceship, as they call them, the bird. It's the Cassini spacecraft, the one that went up to Saturn in the early 2000s.
Oh, wow. That's impressive.
Yeah, so that was a pretty cool project, that we were on the Cassini program, and we made these waveguides that actually one of our parts went up on around the Cassini spacecraft. That was a pretty cool project.
Oh, that's very cool. Very impressed.
Yeah, the other one is, from toy manufacturers. We made some pretty cool toys and medical stuff we've done. And a lot of government projects were pretty cool. The government stuff is going into, we're making parts that go on drones and go on aircraft right now.
Mm-hmm.
I mean, they're actually using parts. And what's cool about the technology for our aerospace clients is that they need short runs and they need small quantities. They're not going to make 50,000 jets,
Right.
They make a few hundred of them. So they need low volume manufacturing. And that's a tough thing to do because you usually have to go to a machine shop. You can't afford a $40,000 injection mold that's going to make a lot of parts. So they usually machine them. They go to a machine shop and get them, 50 of them or 25 of them at a time. And they like low volume, short run stuff in manufacturing. That's always been a problem, low volume, short run, because of the tooling that's required or the cost.
Right.
But with 3D printing now, it's like a fraction of the cost, and they could do them really quick, and they could order them in what they call just-in-time manufacturing, JIT, where no one wants to inventory parts anymore. They want to buy parts as needed.
Right, which is helpful for the spare parts business as well.
Absolutely. So the some of the projects we do for the government is pretty cool. And a lot of the projects were pretty cool, but Cassini was the one that really stuck home with me as an interesting one.
Definitely the marquee project for sure.
Yeah.
So, for folks out there that might hear the podcast and they're thinking about what you do and how it might apply to their business, how does someone think about, do I switch from what I'm doing now, either the injection molding or the machine shop, and think about what SICAM can provide?
That's a great question. One of the challenging things we're doing right now in the marketplace is because people are used for 3D printing for prototyping, not for production. And now we're making this transition in the last 4 years of production, short run production. So we really have to convince them or not convince them, more or less, we have to walk them into it and say, look, not only can you produce this part anymore for your prototypes, but it's good enough to use for production. Where before they never thought it was good enough to use for production. So their mindset, the engineer, was always to use it for prototyping and rapid prototyping. And until we got them convinced that this is good enough for production, and they started developing it with the new technology in the last 4 years, all of a sudden their eyes lit up. And they say, hey, we don't have to buy a mold anymore. We could just use these parts that we made, that we prototyped with now. So they're starting to migrate into manufacturing with the technology, but it's a learning curve.
Like anything, you have to get the buyer to trust the quality and the durability of the product, right?
Absolutely. I mean, that's one of the things about manufacturing and making parts for people. They have to be high quality, and they have to feel that they what you're doing, and that they trust you in making parts for them.
Exactly.
Yep.
Well, this has been a great discussion, and I love getting introduced to businesses like yours that are doing this amazing work and using cutting edge technology in a place right in our backyard, like I said. So thanks so much for sharing a little bit.
Well, absolutely. Thanks for having me on. And, it's interesting that we talked, and it's a great subject for people to hear about, I guess.
Well, if they'd like to reach out to you after the podcast to learn more about you and SICAM, let us know where they can do that.
Well, we have a website naturally, SICAM.com, SICAM. It's and you could get to that website, and there's registration things there, or there's areas for contacting us. So the best way is on the website. I mean, just have them go to the website. And
fantastic. Well, thanks for sharing.
Listen, Chris, thank you for having me on. Thanks for having me on.
It's been a blast.
And it's been a pleasure meeting you.
Thank you. It's the same for me, like I said. And just to sum it up, this has been Pete Sayki from SICAM Corp in Hillsborough, New Jersey, talking about the amazing work that they're doing in 3D printing. And thanks for listening. This has been Chris Santamassimo from the Think Factory podcast, and we'll see you next time.